Okay, so can you hear me now properly? Hello, can you hear me?
Oh, yes, I can hear you.
Okay, so let's go start out today's session. Basically, today is our sixth number of class. So basically, today we have discuss about that machine learning topic, how we can easily work with the machine learning in Google Earth Engine platform. So let's go. Just simply share my screen and then try to. Okay, so basically today we try to discuss about that machine learning in Google Earth Engine and how to make land use land cover mapping using machine learning, mainly supervised and unsupervised method. How can they apply different types of supervised machine learning models such as random forest, then classification, regression trees, then support vector machine, minimum distance classifier, how we can easily use in Google Earth Engine platform and make the land use land cover classification, and how to check the land use land cover accuracy assessment using Google Earth Engine, overall accuracy, kappa accuracy, producer accuracy, consumer accuracy. So this type of accuracy, how can easily check using Google Earth Engine platform? We also talk about that and calculate the land use land cover classes area. Suppose how much area for the vegetation, how much area for the build up, how much area for that water body. So this type of classes calculate the area. We will talk about that. How to add the legend on our LLC map, okay, and how to export the land use land cover classification map in Google Engine as a TIFF format. So let's go. I simply open my slide. So machine learning in Google Earth Engine platform, mainly we can work for that in machine learning, mainly supervised, unsupervised, and regression using Google Earth Engine. So supervised machine learning, it's one kind of machine learning where we need the ground truth data, and ground truth data, when you want to work, you have to take some ground sample. Okay, so in this time there are a lot of way to take the ground sample. If you want, you can take the physically visit your study area and take the ground sample data and then use it as a ground sample, or if you want, you can also take the training sample from your satellite images based on the different types of band combination. Okay, so supervised machine learning model, you must take the ground sample data or ground truth data and then make the training sample and then work with that. But unsupervised machine learning model, you don't need to take any kind of ground sample or ground truth data. So it's mainly work for the clustering. Just it find out the similarities between that uh, pixel and then make the group or make the class. So unsupervised machine learning model, you don't need to take any kind of ground sample data. But supervised machine learning model, you must take the ground sample data for make machine learning model. And unsupervised machine learning model don't need to take any kind of ground truth data. And regression, mainly it's one kind of model. It work for the different types of prediction, such as water quality or percent forest cover or percent cloud cover of crop yield. So it's referred to the linear regression. Using the linear regression, we can easily predict anything about that, what's the happen for that future about that. So we talk about this type of things. So let's go. So first of all, classifier. So what is the classifier in Google Earth Engine platform? So classifier is one kind of algorithm. Suppose which model or which algorithm I want to use, it's just called a classifier. Classifier can be random forest. Classifier can be classification regression trees. Classifier can be support vector machine. So actually, which algorithm I want to use in my model, it called as a classifier. The algorithm which you implement in your classification and dataset is known as the classifier. And mainly there are the two types of classification you can do. Suppose one is the binary classifier. Binary classifier, this outcome we can get only for the two outcome for the binary classifier. Suppose you want to make the classification only for that water body and suppose vegetation. Suppose you want to make the classification only for that two land use land cover classes. such as suppose cropland and vegetation. So this only for the two outcome we can get from the binary classifier, as well as also yes or no, male or female, spam or not spam, cat or dog. So binary classifier, it has only two possible outcome, but multi-class classifier, mainly it's more than two outcome. Okay, from the multi-class classifier we get more than two outcome. It called the multi-class classifier. Suppose crop types classification, classification types of music, land use, land cover classification. Okay, so when we can get the possible outcome more than two, then it's the multi-class classifier. So for the multi-class classifier we have used some specific algorithm. For the binary classifier we have used some specific algorithm. Suppose for binary classifier it's work very well for the support vector machine. This algorithm work very well for the binary classifier. Suppose when you want to work for that only for the two classes in your project, then you have to use the binary classifier. Binary classifier, it can be support vector machine, we can easily use, and then we can easily work with that. And for the multi-class classifier, if you want, you can use here the random forest classifier. It also work very well, as well as also classification regression trees. This algorithm is also work well for the multi-class classifier. So further we talk about the example one by one. So in this time, when you want to make the land use land cover classification map in Google Earth Engine platform, we have to follow some step, such as first of all we have to selecting our study area. Suppose which area you want to work for land use land cover classification map, you just need to draw the study area. Okay, mainly it can be your boundary shape file. Okay, so first of all you have to select your boundary shape file, and this boundary shape file you have to import in the Google Earth Engine platform. Okay. Then you have to choosing and filtering the image collection. In this time you can choose the Lancet, or you can choose the Sentinel, or you can choose any satellite imagery. These are available in Google Earth Engine platform. Okay, so you have to choose and filter your image collection, and then you have to collect the training point. So it's the third step. So in this time, if you want to need the ground sample data, you can simply go to the ground and take the some training sample. Suppose basically it's need when you want to work for the crop classification. Suppose you want to make the different types of crops classification. For that you have to need take some different types of crop training sample from the ground. Okay, as a GPS location, mainly coordinate, latitude and longitude. Further, this type of latitude longitude we use as a ground truth data in Google Earth Engine platform. So basically, in the normal classification, suppose normal land use land cover classification, don't need that. We can just take the training sample from the satellite images. But when you want to make the crop classification or species classification, for that you must need the ground sample data. Okay, so this data we have to use in machine learning model, and then classify the different types of crop or other things. And for this step we need to merge all of this training point. Okay, so all of this training point we merge after collecting the training point, then we merge all of this training point in stored in a one variable. Further, we have to make a training data set by training sample regions. So in this time, we have to make a training data set. It's called the spectral signature we create for each bands. We are use some bands, suppose red, green, blue, near infrared, short wave infrared. So this type of bands we are used, and then extract the pixel value, band pixel value, is band pixel value for each training point. Okay, so then it created a data set. So this data set further we split in two way. Suppose some data set I want to use to train my model, and some data set I want to use for test my model. So in this time, if you want, you can use at the different types of ratio. Suppose 80% data you have to use for train your model, and 20% data you have to use for that test your model, or 70% data you want to train your model, or 30% data for test your model. So different types of ratio in this time you have used, and then split the data into two way. Further, we are just making algorithm using classifier. create the classifier. Mainly, you can use the different types of algorithm. It can be random forest or support vector machine or classification increase, and then classify the image, and then create the classified image, and then display the result, and then print the conversion matrix table for accuracy assessment. Rest of the 20% data or testing data. This testing data we have to use to make the confusion matrix table or check the validation first. Then after, when you want to make the confusion matrix table, from the confusion matrix table you can easily check about the overall accuracy or kappa accuracy or producer accuracy or consumer accuracy. All of those things we can easily check from here, and then calculated the area of each land use land cover classes. So this is the step we follow, and then you can easily make the land use land cover classification map. So let's go try to discuss one by one all of those things practically. It also better. So just I simply open my code editor. Okay. So first of all, I simply import my study area. Suppose I want to work for the Dhaka city. So I simply import my study area, and then further I just simply rename it. You can put any name. I put the name suppose RY. And now I display my study area. So map.add layer, suppose RY, and also focus the center of this boundary shape file. So use your map.center object. Object is RY. Zoom level suppose 10. Click to the run. So this is my study area. It shows the Dhaka city boundary. I want to make the land use land proper classification map for this study area. So now, first of all, I simply select my study area. Okay. And now, second step, we have to choose and filtering the image collection. If you want, you can use the Lancet, or if you want, you can also use the Sentinel. Both of images is the same process for making the classification. So second step, just we take the choose and filter the image collection. Suppose I just work for that Sentinel image collection. So simply click on here, and then click on the Sentinel. And Sentinel 2 multispectral instrument. And I want to work for that. Basically, land use landmark classification map. We are using here the surface reflectance. Okay. So now I simply copy this snippet and paste in here. Then give a name. Suppose I put the name is that image. So this is my image collection. In the meantime, I also give you an announcement for our upcoming online training program. So basically, this class will be start from the 19 April, and the admission last date is 17 April. Now, only for 6 seats are available to get the 50% discount on this online training program. So basically, this is our online training program for beginners who don't have any knowledge about the Google Earth Engine, or who don't have any knowledge about that JavaScript, Python, or Google Earth Engine. So anyone can easily learn all of those things from beginners to advanced level. And class will be take only for the Friday and Saturday in a week. And this is the class time about that. And if you want to join this online training program, you can simply contact with this WhatsApp number. You can also contact with this email. And you can get all of those things in here. You can see basically this online training program totally for beginners. Suppose you have no knowledge about the coding such as Python or JavaScript or Google Earth Engine, don't worry about that. You are able to learn all of those things from beginners to advanced level, and you can easily apply this Google Earth Engine platform for different types of remote sensing analysis after completing the total 7 days online training program. So here you can see all of this course content I already added for first day, second day, third day, fourth day, fifth day, sixth day, and seventh day. And here you can see about the course benefit. When you want to join this online training program and submit all of this assignment, you can get the course e-certificate. You can easily get all of those material, mainly slide, PDF. You can get all of this practice code. You can easily get all of those recorded class, as well as you can also get the lifetime teaching support. It's very important as a beginners, because when you want to learn the Google Earth Engine platform, you face a lot of problem. That's why we're also providing the lifetime teaching support. So that's why you can easily learn all of those things from beginners to advanced level on Google Earth Engine. So if you want to join this online training program, don't waste your time, and to get the 50% discount as soon as possible, contact in this WhatsApp number and also contact with this email and book your seat. So thank you. Signal 2. So now this image collection I need to filter according to my region of interest, according to my time period, according to my cloud cover. Okay. So really where, when, and how. So let's go if we try to filter this image collection. Where I need this image only for the Dhaka city. So just I simply use the filter bounds and call the Dhaka city. Dhaka city is already stored in a variable whose name is the RY. Okay. Then how I need this image? I need this image for the less than 1% cloud cover. So I put here the filter metadata, and further I just try to click on the image properties, and from the image properties I choose the cloud pixel percentage and paste here, and further just put here the filter date. Suppose I want to make the map year of 2023, 1st January from year of 2023, December 31, this time period. And this time period, you want to check how many images I want to got. Okay, suppose I simply print and image and then use there the size. So now it shows you that how many images are available between this time. Okay, we have to use at the operator, sorry, less than 1%. So put here that less than 1. So now it shows you the result. We can get the 29 images. Okay, and if you want, you can also check about the time period about that. Just simply remove the size function, only print the image. Then we can get all of images, also time about that. 29 images is images 23 band. Okay, so go to the feature. We can easily get the all of this information about this image. You can see. So in this time, suppose you want to work for the single image. So for that, click on here and then copy this ID. You can see this is the ID, single image ID. Copy this ID and then work with that. When you want to work for the single image, just take a variable. Suppose I put the variable name is the image and put here ee dot image and put here this ID, and further clip it with study area ROI. So click to the run. So now I want to add the layer about this single image. So just use there map dot add layer and call the single image. Okay, so now it will be added this single image as a layer. Okay, we can get this type of image. You can see. Okay, so it's a single image. I just choose the single imagery and then make it. So further, you can simply click on here and add the color, suppose red, green, and blue band. So now you can get the true color composite. Okay, so I can get this type of image for the single net. So now we can easily use this image to make the land use land cover classification map or any other one for that. Okay, but in this time I want to work for that median composite. So suppose I just take all of those images, 29 images, and make the median composite. So for that I just use here the median function, and further I just clip with my study area ROI. Okay, so now it will be stored in this image, and I want to add the layer about this image. Okay, but when you want to work for the single date image, just apply copy this id and then work with that. Okay, but in this time I have to create the median composite, so that's why I just create the median function and then clip with my study area. So now I want to visualize this image in here using the map.add layer function. So click to the run. In this time it create the median composite, and this median composite created from total 29 images. Okay, we can get this type of imagery. So further I simply click on here, and I want to, in this time here you can see another problem which show the range is not good. Okay, because you can see this image already have a scale. You can see they already provide the scale. Okay, so in this time I need to scaling. So just I simply copy the scale, and all of band have a same scale. So just I try to scaling this imagery, then we can also get the better. So for scaling, we are just use here multiply function, multiply with this scale. So now click to the run again. So now click on here. Here you can see about that. I simply add here the before red, green, and blue, and custom as stressing 98%. So now you can see we can get the proper range about that. Okay, and now try to apply. Okay, and also import this, and then simply copy this visualization parameter and paste after the object name. So this is my object, and I want to paste in here. I put the layer name. It's a image. You can put any name as a layer. So now our second step is done. Okay, we just take this type of satellite imagery, and now this satellite images I want to use the different types of algorithm and then make the classification. Mainly in this time you can easily classify it. Suppose I want to classify it from this image for build up area, suppose vegetation, barren land. Okay, so this type of things, water body, I want to classify it from here, and then try to calculate the area on all of those things. I try to do that. So this is my image. Okay, so in this time we are applying that supervised machine learning model. Okay, mainly when you want to apply the supervised machine learning model, you must need the sample, training sample. Okay, and training sample we are using the different way to make the training sample. If you want, you can simply go to the physically visit and take the training sample as a GPS location, or if you want, you can also take the training sample from the satellite images using the different types of band combination, and then you can easily take the training sample of each classes such as water body, vegetation, build up area, barren land, or any other classes, and then work with that. So this is my image. So in this time I want to take the training sample from this imagery, and first of all for that I want to use here the different types of band combination. Okay, so in this time it's called the true color composite. Okay, mainly red, green, and blue, RGB color. Basically it's the true color composite what human eye can naturally show. So in this time we can get the naturally vegetation show as a green color. Okay, it naturally show about this type of things. Okay, also you can see about that we can easily identify it's a one kind of lake. So it's a water body, we can easily identify it's a water body, and we can easily get about that this type of things is the building or build up. Okay, it's a water body, naturally we can get it, it's a natural color, it's called that true color composite. Okay, so as well as we will also apply the different types of band combination, such as when I click on here I can easily change the band combination. Suppose near infrared, which is B8, near infrared, then red and blue. Suppose custom stressing 98%, and then apply. So in this time I can get the other band combination. In this time water body show as a black color or dark color. You can see water body show as a black color. or dark color. Okay, and vegetation show as a red color. We can get the vegetation as a red color. Better red identify better vegetation. Lower red or reddish identify for that low vegetation area. And water body show as a dark color or black color. We can see the water body, and we can get the barren land, this type of gray color, or this type of gray color we can show as a barren land, and vegetation show as a red color. Okay, so it's a one kind of band combination. So mainly when you want to use this band combination, all time we can get the water body as a black color, and we can get the barren land this type of gray color, and vegetation show as a red color for any region. Okay, suppose you want to make the land use land cover classification map for unknown region, which region you don't visit physically. So for that you have to use the different types of band combination and then try to identify for the different types of feature. So you can see water body show as a dark color, so it's a water body. Also you can see it's a water body. Okay, also you can see it's a water body in here. Also you can see it's a water body. Okay, so it's one kind of band combination. It's the near infrared, red and blue. It also similar for Landsat also. Okay, when you want to work for the Landsat imagery, also same. So in this time I talk the another band combination, which is short wave infrared one band, and then near infrared band, and then green band. So it's a one kind of band combination. So in this time when I want to put this band combination, then we can easily identify the easily. Suppose in this time we can easily identify about the vegetation as a green color we can get, and we can easily get the water body as a black color or dark color. You can see it's a vegetation. You can easily get this type of things. We can easily get about that. You can see the gray color. It show the this type of barren land. Okay, it's a barren land. Also you can see the barren land. Okay, and in the barren land we also get this type of color. You can see. So basically it's one kind of wetland. Okay, it's identify about the wetland. You can see, and this type of color identify about the barren land or fallow land. Okay, we can get the two types of barren land. One kind is that wetland. Here you can see this type of color identify about that wetland. Okay, it's a one kind of dark gray color. Okay, and it's a light gray color. This type of light gray color identify about that only barren land or dry barren land, and it's a wetland. This type of color. You can see this type of identify about the wetland, but you can see this type of gray color only for that. It show about that dry barren land. So in this time you want to make the classification for wetland or barren land, you can just take the training sample from here for as a wetland, and you take the training sample for that barren land. Then we can easily classify the two things about that. And also you can see the vegetation. So this type of vegetation you can get from here. And this type of the water body you can easily get from here. Okay. So in this time we are just take the training sample and then try to make the classification. So how I can take the training sample? For taking the training sample, you can simply click on the marker. You can see the marker tab, and further it shows the geometry. So I simply click on here, edit layer properties, and then further try to add the geometry. Suppose I have to take the training sample for water body. So just put here the name water, then import as feature collection, property, set the property. I set the property name, suppose class, and value for water I set suppose 0. Okay, so all of those training sample of water body I consider the level as a 0. 0 means water body. Okay, so just click on here. So now I try to take the training sample from here. So just click on this water body and take the training sample from here. and how much training sample I want to collect for each classes. So basically in machine learning model, we don't need to put the more training sample. It depends on your study area. Suppose when you want to work for the big region, then you try to work for that more than 50, or a small region more than 30 is enough for that. Okay, and it also depends on your accuracy. Suppose you did not get the better accuracy, then you try to add the more training sample. Suppose after running this model, I did not find the better accuracy, so further then I want to increasing or decreasing my training sample of each classes to achieve the better accuracy. Okay, so basically this is the process. I take the training sample for the water, and further I just click on here and take the training sample for suppose for vegetation. So click on here again and put here a name about the vegetation and geometry feature collection. Set the property suppose class and put the value for 1. So in this time we consider all of those vegetation training sample name or label as the 1. So click on here. So now we are just take the vegetation. You can see this type of green color pixel. I simply take the vegetation from here. Okay. So I take the training sample for vegetation, and further I take the training sample for suppose barren land. Suppose it's a class, and then put at the 2. So all of those barren land we consider as a mainly class 2. So 0, 1, 2. So in this time, suppose this type of things here, you can see this type of gray color considered as a barren land. So just I simply take from here. It's a barren land, and this type of things it's considered as a wetland. Suppose I just take this training sample from here. Okay, as well as I take the another suppose wetland. So click on here. And okay. So in this time you can say 0, 1, 2, 3. So just you can take the same training sample, this type of reddish color. Okay, so we take this training sample for the wetland also about that. And further, I take the training symbol for build up. So just click on here. Build up. Feature collection. Set the property. Property name is the same for class. And put at the foot. Okay. So in this time, if you want, you can also change. Suppose I have to put the another band combination. Suppose red, then green, and put at the blue. Apply. So now I can take this time training sample for the build up. So it's a build up. So now I can see we can get this type of build up training sample. Okay. So now we are just in this time, you know, our third step, we just take the training sample for water body, vegetation, barren land, wetland, and build up area. Total 5 classes. We take this training sample. After taking this training sample, we move to the fourth step. In this time, we merge all of this training sample. So in this time, just simply merge all of this training sample. Okay, anyone any question? Okay, so in this time for natural unit, mainly we talk about that natural band combination. So basically band combination is doesn't mean anything. Suppose in this time we can use any kinds of natural band combination. It can put any kinds of band combination. It can be natural or it can be false color or any kinds of band combination we are use. It doesn't mean anything because in this time we are just use the band combination, just take the training sample, just only for that. But which band I want to input in my model, I define it further later. Okay, so in this time Which model I want to import? This model I need to input some band. So we define it later. So in this time we are just use here the band combination, different types of band combination. Just identify the different types of feature properly. Suppose when I use here the other band combination, then I can easily identify for water body, build up, vegetation, or anything. So in this time, it's only show the visualization for the different types of feature on the surface. But when I want to work with my model, then I have to need to some input. Okay. So in this time, we trying to input. Suppose which band I want to use in here. Further, we are use the model. It can be random forest or neighborhood or anything. We can put any model or any classifier we can use in here. So let's go one by one. So first of all, in this time, it's our fourth step. Fourth step, we take the merge all of the training sample and store in a variable. So just take a variable. Suppose I put the variable name is that samples and merge all of the training sample one by one. Suppose water merge with vegetation, it merge with barren land, then merge with wetland, then merge with build up. Okay, just we are merge all of training sample and store it in a one variable. So now you are just simply print the samples. Here you can get all of information about your training sample. How much training sample you can take in here, we can easily get it from here. So you can see the feature collection, and it shows that 248 training sample we can collect for all of classes. And we already make the level or pre-categorize all of training sample. So here you can see it already show about that pre-categorize. Suppose I click on here, I can check about the level. So you can see about the level is that class 1. Okay, so class 1, it's a level. And what is the class 1 for? What is the class? So class 1 mainly vegetation, because you can see I put here the level is the value is the 1. So this training point I already pre-categorize. I already put the level. This training sample we already provide the level. Level is the 1. 1 means vegetation. Suppose you try to check the another training sample from here. You can see the class 3. So this training point I want to use for that. You can see 0, 1, 2, 3 wetland. Okay. So this training sample I already pre-categorize as a 3. So it's the label. I set all of level. So now I want to make a data set. Mainly I want to extract the spectral signature of each point for a specific band. Okay. So in this time I want to make a list of band. So in this time we talk about that fifth step. Mainly we try to extract the spectral signature. So first of all I take a variable, suppose bands. In this time, which band you want to add in your model, you just write the name. So in this time check your image collection. Here you can see this image have this type of band B1, B2, B3, B4. So this type of band is available. But in this time I want to work for 10 meter bands and 20 meter bands. Okay, so I want to work for the B2. I want to add the input, then B3, then B4, B5, B6, B7, B8, B8A, then B11 and B12. So just I make a list all of band which I want to work as input. So put at the B2, then B3, B4, B5, B6, B7, B8, B8A, B11 and B12. Okay, so in this time I want to work on this type of band B2, B3, B4, B5, B6, B7, B8, B8A, B12 and B11. So all of those band have a specific spectral signature, mainly band's value. So in this time, suppose this point, this specific point, what's the band value? These specific points, what's the band's value? All of band. I want to extract the pixel value, band pixel value for each training sample. Each training sample, just extract the band pixel value, and it's my data set. So let's go how we can easily extract the band pixel value. For doing these things, just take a variable. Suppose I put the variable name is that training, and call my image and select specific bands. Basically, this variable stored all of bands. So just I select these bands and then use a function sample regions and put all of those things one by one. So just make a curly bracket start and also curly bracket in to make a dictionary. So first of all, collection mainly your sample, how much training sample you want to use in here. So I simply copy these samples and paste here all of training sample. Properties, so basically it's a property name. When you can see we want to already provide the property name, here you can see the property name is the class. So just I put here the same property and put here the properties, so put here the class, and you can see here it is the plural form properties. So that's why you have to use here the square bracket. Okay, so basically it's a plural form and all of property is the same. All of classes we are using the same property class. Okay, so just it's a plural form as a list, so that's why you have put here the square bracket and then put the property name. Then scale means resolution. This time we consider it as a 10 meter, and projection not need, remove that it's not need. So in this time we are just printing, suppose just print this training. So now it extract all of those training sample for each classes, for each point we can get. So click on here you can see the feature. You can see, suppose on this point, click on here you can see it extract all of those band pixel value for this specific point. And what is the level about the 0? Okay, 0 mainly it's a water. So I can get for that training point this type of band pixel value for each point. So it's called the spectral signature. For also you can see all of point extract the pixel value, band pixel value for total this type of band. Okay, suppose you can see it extract the B11, B12, B2, B3, B4, B5. So all of those band pixel value extracted. So it's my data set. Okay, so further we use this data set and make the classification. So all of training sample extract the band pixel value, which band I want to mention in here. So this type of band pixel value extract for each point. Mainly how much training sample you can get? 248 points. Extract the all of bands pixel value and make a data set, and this data set is stored in this training variable. Okay, so now this data set I need to randomly distribute it. So now we try to use the randomly distribution, and then we use here the 80% data, suppose train, and 20% data for test. Okay, just spilled. So randomly distribution we do, and then 80% data for train and 20% data for test. So let's go, we try to take a variable. Suppose I put the variable name is the data set and call the training. This training is stored the full data set. So this data set I want to randomly distribute it. So for that we are just using the random column function. So mainly when I put at the random column function, it randomly distributed this data set and stored it in this variable data set. So now this data set I just filtered into 80% and 20%. So just take a variable. Suppose I put the variable name is that train set and call this data set and paste here, and then just filter. How I can filter? Earth engine dot filter greater than random 0.8. and then take the another variable test set. Just call this data set. I want to filter pe dot filter less than equal random 0.2. So here you can see we just simply split the data set, train set and test set. So this train set we are used for train our model, and this test set we are used for check our validation. So in this time